Alright, exciting tutorial ahead. Today we're going to build our very first multiple linear regression, and we're going to be using the backward elimination method. I hope you're pumped about this. Let's get straight into it. Open up Gradle and let's connect to our data. File, open data. Mine is on my desktop. Modeling section, multiple linear regression. So it's a CSV file. There it is. That's fine. We don't need to do that. And the first thing you can see here is that Gradle has identified that we have a categorical variable. It says variable 4, which is called state, is a string. So it is warning us that we're going to have to deal with this. And there's two categories, New York and California. So very, very convenient. Now we know that there's two categories. So let's go ahead and deal with these dummy variables right away. As we discussed previously, because we have a categorical variable, we can't just include it in our multiple linear regression formula equation because that way it's not a number. So we need to replace it with some dummy variables as we discussed before, and that's exactly what we're going to do here. It's very simple to do in Gradle. All you have to do is select your variable, go to add, and down here it actually has an option, dummies for discrete variable. Click that, and here make sure you're encoding the right variable. And here you have three options: encode all values, or you can skip the lowest value or the highest value. And Gradle is smart like that. It knows that you won't be able to use all of your dummy variables in your models anyway. You're going to have to omit one of your dummy variables. And we discussed that also in this course just previously when we were talking about the dummy variable trap. Because you can't, if you include all of them, then your model won't work. So it's right away, it's offering you to skip one of them. But as we agreed, we're going to encode all, and then we'll select the one we want to use ourselves, because that gives us a bit more flexibility. So we'll just click OK here. And if you expand state now, you will see that there's two dummy variables, dstate_1 and dstate_2. And one is for New York and one's for California. We don't want to remember the names and which one is for what, so we'll just quickly modify the names. Right-click your variable, click Edit Attributes, and here take New York and put it in the name of the variable. So we'll just call the variable New York. You can't have spaces, so get rid of the space. Click this check mark here, and then proceed to the next variable by clicking the down arrow. Take California, and same thing. Okay, so now we have two dummy variables, New York and California, and they're ready. Great, we're ready to proceed with our modeling part. So I've put a picture over here of our previous slide. By the way, I didn't mention this, but I am intending on attaching the slides as a downloadable file to the previous lecture. So go ahead and download that in the course materials, and you can keep this file for yourself and refer to it whenever you need to. So this is our building a model backward elimination method. Our first step is to select the significance level for variables to stay in the model. In our example, we're going to use 0.05. So I'm going to say it out loud. I am selecting the significance level to be 5% or 0.05. Good, step one done. Next, fit the full model with all possible predictors. Let's go ahead and do that. So model, ordinary least squares, and here we're going to take profit and we're going to move it into our dependent variable. And because we're going to be doing this process quite a few times, it's going to be an iterative approach. We're going to click this box here, set as default. So every time we come back to this menu, profit is already the dependent variable. And now let's go ahead and move our independent variables into the regressors box. We'll start off one by one here. R&D spend, so spend on research and development. Yes, that's one of them. Administration expenses, yes. Marketing spend, yes. State, no, because we've agreed that we will replace state with dummy variables. Profit is our dependent variable, and now we have two dummy variables. We can only include one in order to avoid the dummy variable trap, and we're going to include the New York. Well, I'm going to include the New York one. You can feel free to include whichever one you like. So there we go. Our regressors are ready, and all we have to do is click OK. Voila! Congratulations! This is your first multiple linear regression model. And as you can see here, you have the 4 variables present plus the constant, you are modeling a dependent variable profit. And let's have a look at this. And now we know how to read these. Let's extract some information from here. So these are our coefficients, and we'll talk about interpreting coefficients in the next tutorial. So we'll leave that for now. We're not going to focus on the standard error or t-ratio. What we're interested in is in the p-value, right? So we've got the p-values for all of our 4 variables. And here you can see some stars, meaning that it's a good p-value. It's a significant variable because it is so small. It is 7 times 10 to the power of minus 22, a tiny value. These values are quite large, actually. So 0.65, 0.12, 0.62. So that's why they don't have stars. You get, I think the way it works is you get 3 stars if you're less than 0.01, 2 stars if you're less than 0.05, and 1 star if you're less than 0.01, so 10%. So that's how this rating system goes. Anyway, let's go back to our backward elimination step-by-step method. So we've run the full model with all possible predictors. How about we do the next step now? Step 3, consider the predictor with the highest p-value, right? So let's go ahead and look at him. Predictor with the highest p-value is this guy, administration. He's got the highest p-value. Good, we've picked him out. Next, if the p-value is greater than the significance level, go to step 4. Let's check that. P-value is greater than 0.05, definitely greater. So we're going to step 4. In step 4, remove this predictor and fit the model without this variable, and then move back to step 3. Okay, that's interesting. Let's go ahead and do that. So basically what that's telling us is run a new model but without this variable. We're going to do exactly that. We won't touch this window, we'll leave it open, and we'll go back to Gretel. And here we're going to go model, ordinary least squares, and now we're going to take administration out of our model. So we'll just remove it like that, and we'll click OK. So now if we go back here and put it side by side, you will see what happened. Now we have 1 variable less. So here administration is present. Here administration is no longer present. And also you can see that some things have changed. So for instance, the constant has changed, the coefficients have changed, the p-values have changed. Basically everything has changed. And even a star has appeared for marketing spend. So before it was so large, so it was 0.12, it was greater than 10%. Now it's less than 10%, so it's got a star. So it became more significant without the administration variable present, and that happens. That's normal. That's there's lots of factors that influence that, and excluding or including variables will always affect your existing variables, and that's one of the reasons why you can't just exclude administration and assume that everything else stays the same. That's exactly why we have to rerun the model. And so we're ready to proceed to the next step. But before we do, I wanted to show you one quick thing, a good exercise to do. And this is not part of our step-by-step method, and this is also not the awesome tip or hint that we're going to look at to make the model robust. This is just something for us to understand what happened here. A way to understand is always a good way to understand is always to visualize things. So let's go ahead and visualize this variable, or visualize the profit against this variable if we hold the other variables constant. It's very simple to do. Just go to graphs, fitted actual plot, and here select against administration. And what that'll do is it'll plot profit against the administration variable, assuming that all other variables are held constant. And so the blue values are fitted, the red values are actual. So ignore the blue values for now. What we're looking at is that, is there any kind of relationship, any kind of obvious relationship that we can see between profit and administration? So is there like we used to see, like a line that we can draw that goes through the variables or the values, and it's quite close? To me personally, it looks like there is no relationship, and like it's all scattered all over the place. And what that means is that even if you change administration spend, so how much money you're investing into your administration or how much that expense is. If you increase it or decrease it, you can't really affect profit. So by changing this independent variable, the dependent variable is not affected. And that is exactly why we chose to exclude administration from our model, because it is not a predictor of profit. You take two companies that are identical, but they spend different amounts on administration, you can't really tell which one will have a higher profit, or you can't even, according to our model, make a prediction. So we're going to close this window now. That should kind of explain a little bit better, more intuitively, what this means that we're excluding a variable from our modeling. Now we're going to move on to this part. We're going to proceed with the next step of our backward elimination process. So I'm going to bring up the rules again, and here we can see that we've just fit the model without the new variable, and now we're going to do this part again. So consider the predictor with the highest p-value, check if p-value is greater than your significance level, and if it is, go to step 4. Let's go ahead and check that. So we'll find the variable with the highest p-value, which is this one, New York. So our dummy variable has the highest p-value, 0.57, very high p-value, definitely greater than our significance level, which is 0.05, and therefore we need to exclude this variable from our model as well. Let's go ahead and do that. Model, ordinary least squares, take New York and take it out. Click OK. And let's move this window over here. All right, so what have we got so far? We've got two variables. Once again, coefficients changed, the constant changed, p-values changed. As you can see, this p-value got even smaller. It's now 0.06. It can really go both ways. You never know until you actually run the model. But now we've got a new picture. We've got two variables, and we're ready for the next step. Once again, you can quickly check the graph if you like. Go to fitted actual plot, and here we want to check against New York. So look at the reds again. Basically, because it is a categorical variable, or this is a dummy variable now. So 0, 1, remember we're talking about the on-off switch. So are you in New York? Yes. Are you not in New York? Where else can you be but California? So you're in California. So, but basically what is this is saying is being or not being in New York is not really, doesn't really make a difference. The way, if there was a difference, you'd see like a lot of red here and a lot of red here, meaning that if you're in New York, your profit is much higher than if you're not in New York. But here it's kind of evenly distributed across, like across the whole line here and across the whole line here. So no wonder we were suggested to exclude that variable from our regression. It doesn't really predict anything. It's not that much of a predictor. So that's why we took it out. All right. So now we're doing the next step again. We don't need to go back to rules because by now we should remember them. Look for the highest p-value. It's this one. And check if it's greater or less than our significance level. So 0.06 is quite close to 0.05, but it's still greater than 0.05. So what does that mean? We need to exclude this variable. Let's go ahead and do that. This is our Gradle software, and now we're going to go order least squares. Once again, which one is it? Marketing spend. So we're going to take it out and we'll click OK. And now we'll move it over here. Okay. Let's have a look at what we have now. So now we have only one variable left. It's very significant, lots of stars. It's definitely less than 0.05. So what does our method tell us? Let's go back to our method. Here, our method would say that we've only got, we get to this part. This is not true, as you remember. That means we don't go to step 4, we go to fin. Your model is ready. Good. So theoretically, according to this approach, this is our model done. It only actually has one variable. We went from 4 variables down to 1. And it's very, very significant. So what I wanted to show you here is, let's do the same thing we did with the previous ones, and let's look at the chart and let's see what actually went on here. Is marketing spend really that not much of a predictor? Let's go to graphs, fitted versus actual, and we'll go against marketing spend. And what you can see here is, even though they're kind of scattered, right? The observations, we're looking at the red ones, and there are some outliers, but in reality, personally, I think I could draw a line for this. I could go like that. Yeah. It does look like there is a good level of correlation here. And that is what we saw here, that marketing spend, it's there's 1 star. Basically that it's not a huge p-value like we had with administration or with New York. It's quite a small p-value, but still it's not sufficient enough for our significance level. And this is the problem with these stepwise regression building methods, that they're very arbitrary. Once we said our significance level is 0.05, we stick to that and we just follow this cold-blooded rule that if it's greater than 0.05, we have to exclude it from our model, and there's nothing you can do about it. So that's the rule, and that's how it works. But in reality, when you look at something like this, you think maybe there is a chance that just maybe I should have kept it in. Maybe my model would have worked better with it. And how do you tell? And this is where I'll show you the handy trick that will help you make your models more robust. And we'll talk about it in the next tutorial.